Now it's a mission to Mars, the world's first lander designed to look into the depths of our nearest solar system neighbour is currently speeding through space on a journey of 485 million kilometres. Expected arrival date on Mars is November 26th. InSight, as the lander is called, will then spend a Martian year, that's roughly 2 years to us earthlings, examining the crust, mantle and core of Mars, taking its vital signs, if you like, to try and tell us what the planet looks like on the inside and whether or not it's like us here on Earth. To tell us more, we're joined by Philippe Lognonné, a planetary seismologist at Paris's Diderot University. Mr. Lognonné, you actually designed the instrument that's being sent to the red planet to take, if you like, its vital signs, and you're just back from that launch that happened at the weekend in the US. It looks like things went smoothly. Are you confident that this mission to Mars will be a success?
Yes, the first step is done. You know, for me, the first step was very strong in emotion because I made, together with my team, another instrument for a past mission. It was Mars 96. So we launched the mission, but we did not succeed to do the Mars insertion. This time, you know, it was 22 years ago. This time we are going to Mars. So Go Insight is there. And so we will land on November 26th. So we will have 7 minutes, which will be terrible because it will be blackout for the radio system. We will not know if we land. And when we'll get the first signal, maybe we will there, maybe not.
Indeed. But let's assume that everything goes well and that signal does come back when it lands on Mars. Can you give us an insight then into, if it deploys correctly, what will this mission, what's it trying to achieve? So
it is the first mission going inside the planet. So in the past, we sent to Mars orbiter, we sent to Mars rover at the surface. They scrapped the surface, you know, they took some rocks at the surface, but we really don't know what is inside Mars. And this is key to understand the evolution of the planet, the formation of the planet. To do that, we will take the tool used on the Earth by geophysicists, seismology, geodesy, magnetism, and we will just discover inside. So we will, in some way, we will discover 99.99% of the planet because the surface is only a very thin part of it. Yes.
Indeed, and one wonders, you know, is it to compare what the planet is like? You know, how useful are the findings? Is it to see whether it's like here on Earth, whether life is possible?
In some way, yes. So we are on a terrestrial planet, the Earth. We have a crust, we have a core, we have a mantle. But this is the only planet we know very well. And just imagine that we want to draw a line. So if you want to draw a line, you need 2 points, you know. And we have only this one. This is Earth. So we need to get the second one, Mars, to understand, you know, what is the rule for this terrestrial planet, you know, how much they form with respect to the distance, and more important, you know, what is the evolution in time. So, and the key question is it easy for life to find a planet where, okay, you will have billion years of evolution in order to go to us or to, you know, living and big ETs.
Yeah, just to see the possibilities out there. But as you say, the instruments sent up are similar to the ones here on Earth. Are they actually the same, or you know, are there innovations that you have to take into account, given the atmosphere and everything else on Mars?
So it's more because of the mission. So we have seismometers that will be vibrated by during the launch. You know, we'll get shocks, we'll get very large temperature variation, and therefore this is a very complex instrument. And this is why we made that instrument with our French space agency, with international partner. So more than 200 engineers work in order to make this instrument real. So therefore, in some ways, they take the same idea as the one on the Earth, but they are very, very different.
Hence the decades it's taken to make these instruments. Because we have looked at the inner structure of the Moon, for example, in the past, and other planets. Why has it taken so long to get to Mars?
Oh, because the Moon is very close, you know. It's the Moon is 400,000 kilometers. Mars, so it's really very close, you know. I made more miles to prepare the missions than to go to the Moon. So, but you know, Mars is very, very far. So therefore, we need 6.5 months, so Mars is about 40% further from the Sun than the Earth.
Really a question of distance. And you mentioned there the international cooperation really that has gone into that mission, the US and the EU really working quite closely.
Yes, so this is really maybe one of the first times that a discovery mission of NASA has a non-US principal instrument. The instrument was led by the French Space Agency. We got a lot of support from GPL in Pasadena, my institute. IPGP work a lot, but also we get support from Switzerland, from UK, from Germany, in order to make that and to make that real.
Because it is an expensive expedition. I believe the cost of it touching up towards 1 billion euros?
It's almost $1 billion. So a little bit less in euro, but okay. So this is, it's remained much less expensive than the previous mission or the next one, the Mars 2020 mission.
Okay, well, we'll have to wait, of course, till November 26th to see if that landing does go ahead.
And after maybe in December or first week.
You can tell us what information we're getting back. Well, we would love to speak to you again then, Mr. Philippe Lognonné. Thanks so much for coming into studio.
Thank you.
Mr. Philippe Lognonné, planetary seismologist at Paris's Diderot University.